In this video, we're going to start a study of sequences. So first, let's take a look at what the definition of a sequence is. Well, informally, a sequence is an infinite list of real numbers written in specific order. We call them like A1, A2, A3, and so on. Now, more formally, a sequence is a function from the naturals to the real numbers. And here is a bit of notation. Usually, when you have a function, you write something like f of x. Here, what the term a of n would be, we just denote it by a sub n. And what this tells us is that, well, we use the n instead of x, then that gives us a feeling of that is a natural number. This is just convention, but it's not like it has to be that way. But for us, we're going to try to stick to it, and we're going to denote the terms of the sequence with, for example, a sub n. And here we have an example on the function from the natural numbers to the real numbers given by a of n equals 1 over n. Gives us a sequence that has like a1 is equal to 1, a2 is equal to 1 over 2, a3 is 1 over 3, and so on. And how do we draw the graph of a sequence? Well, you see, here we have isolated points. So what we see, the graph is just a collection of dots that marks that for each n where my a of n should be, but we cannot connect them with a line because, for example, there is not like a of like 4/3, right? That doesn't exist, so there is no way of putting a mark there. So that's why like isolated, like separated dots on this graph. Okay, notation. There is a zoo of notations out there that people use to denote sequences. Some of the common ones are an in parentheses or an parentheses with like from n equals 1 to infinity. Some people use curly brackets and indicating that n starts at 1 and goes to infinity, or just nothing at all. Now, well, let's see how we can go from different notations. So we could have this sequence of 1 over n squared. The general term is the an equals 1 over n squared. And here we have the first three terms of sequence, like 1, 1 over 4, 1 over 9. And the same thing here, we have this one here, minus 1 to the n over 2n. And then we can say, well, the general term of the sequence is an is equal to minus 1 to the n over 2n, sorry. And then here we have the first three terms of the sequence. In this case, is minus 1 over 2, 1 over 4, minus 1 over 6, and well, it would continue. Now, it really doesn't matter where we start. So we could have a sequence that starts 0, so a0, a1, a2, or starts at 17, like a17, a18, a19. So in general, for any integer number and 0, we can start at that point and then continue. And so the more general definition of a sequence is that it's a function from a subset of the integer numbers starting from some point n, and or it contains all the integers coming after that n, to the set of real numbers. So it's a function with domain d, where d is a set of integers n such that n is greater than or equal to some n0. And to start a sequence from some other integer, then we can denote it by indicating where a starting point is. So the sequence an from n equals n0 to infinity. So here, an example, you'll have the sequence like 3, 4, 5, 6, 7. I can start it from n equals 1, and then it would look like n plus 2. But I can start it from n equals 3, and then it would be just n. But if I want to start it from n equals 8, then it would look like n minus 5. So these are just different ways of writing the same sequence with different starting points. Now, there is another very interesting way of defining a sequence, and it's recursively. So how can we do this? Well, I'm going to start with an example. The very famous Fibonacci sequence is defined recursively, and what it gives us is it starts with two initial points. So it says that f of 1 is equal to 0 and f of 2 is equal to 1. And then for the next terms, it defines as f of n is equal to f of n minus 1 plus f of n minus 2. So what it's telling me is that each term is the sum of the previous two terms. And here we have the first few terms, so that's 0, 1, 0 plus 1 is 1, so the next one is 1, 1 plus 1 is 2, so the next term is 2, 2 plus 1 is 3, so that's 3, and 3 plus 2 is 5, and so on. So in general, a sequence is defined recursively by given first the value or values of the initial term or terms. In this case, we had first two initial terms. And then we have to give a rule, usually called recursion formula, for calculating any later terms from the previous ones. We're going to talk a bit more about some of these type of sequences later, but for now, I just want you to focus on the definition.